So these are pivot mount. So what does that mean? It means the cylinder has the ability to pivot. So here you can see the pivots on the what? Cap. Now they called it, yeah, say that. Trunnion, yeah, they're trunnion. Yeah. Here the trunnions are on the back end. Here's the trunnions are where? On the center. Here the trunnions is on the cap end. They just got it turned backwards for you. And here the trunnions are on the head. So here the actual cylinder would actually move, right? You see this a lot. Like on what we was talking about, like on the dump truck. You see that's got to be trunnion. It's usually on the cap end, right? So you ever see those things when they raise them, what do they do? They have to move. They can't be fixed. Cylinder performing work. I don't know what this is. This is a figure. What do they say about this figure? This cylinder performing work. Yeah, and when you calculate your force, by the way, and I know we might have to look at that. It all depends on the load. So that means if the load is sliding against something, then not only you got to compensate for the force needed to move the load, but also the friction that the load is moving against, right? Another thing that's in the math for calculating the load is the angle that the load is at. I mean, the steeper the angle, the more the load, right? Right, and the less the angle, the less of the load. So this is why normally when you want to pick something up, if you move it up an incline, because you're spreading that work over distance, right? You can actually link the force. I don't know if that's in this PowerPoint or not. Cushions. So what do we use cushions for? Yeah, that's what we do. Soften it. So when it comes to we don't, most of your cylinders, not all of them, but when you extend that thing, it's going to hit it against the cap, or it's going to hit it against the rotting, right? Well, what we don't want that, a lot of times we don't want that to happen. So what we do is we put these things called cushions in. This could be anything, a piece of plastic or something, or normally it's going to be, what we do is when the piston comes into there, so on the end right here, you can see what we got. We got a little crevice right here that the rod goes into. Well, that's going to be fluid. That's going to be full of fluid, right? You understand? And then notice the pipes that's coming out of the cushion are very, very small. So what happens is we'll come over here, it hits that. Then what's going to do? Well, it's going to take time for that fluid to get through those little orifices. So what we're doing is slowing down the flow. So what would happen is the piston would do what? It would come to the end, and it would literally do what? Slow down before it comes up and hits the cap. So these are called cushions. If I have the ability to adjust this orifice, then what does that mean? Then I have what we call variable cushion. So we can literally play around with that to make that thing slow down or run as fast as we need to without actually banging against the side. So when we come to cushions, by the way, it's going to add another little symbol. Is that in your book? The symbol for cushions. The symbol for the cushion, by the way, is not on the side. What we do is we come up here and we take our cylinder, and then we come over here and we put this in the center. I'm pretty sure, and that means it's a what? A cushion. If we do that, what does it mean? It means it's there. Make sure that's the right symbol, guys. Okay. So there it is. So these guys, notice the two on the right side, these have what's on them? Yeah. No, that's not right either. Yeah. What this is not the symbol for a cushion. That's a symbol for a magnet. What we have is we have the ability, we have a sensor called a Hall effect sensor that can sense a magnetic field. And what y'all probably noticed is we had those sensors where our computer would know when the cylinder was fully extended and when the cylinder was fully contracted. What's nice about pneumatic cylinders is pneumatic cylinders, the cylinders themselves are made out of aluminum or plastic or some form of plastic. All ours over there are made out of aluminum. Aluminum does not block or does not concentrate magnetic field. So what we can do, or what's very popular now, instead of me trying to put something out there on the rod where I can sense where the rod is extended or retracted, we can use devices called limit switches. Most of your cylinders now in the pneumatic system are moving to these guys right here. You see that 1V1 and 1V2 up there at the top? So on diagrams, and nobody in here has asked what that means, B is the term for a sensor. So 1V1 and 1V2 would be two electrical sensors that's mounted on the pin and retract. So what happens, if it's got that magnet built into the piston, then everything's there. I just mount these things on the side of the cylinder, and then when the magnet extends, it trips the sensor, and when the magnet retracts it. Huh? Could be a reed switch. But there's a sensor out there that actually senses when the cylinder is at a certain location. And then when we go to automation, automation means, what does automation mean? Automated. If something's automated, what is it? What is automation? It means it works with little or no human intervention. That's what automation means. Little or no. Well, when we get into automated systems, these computers have to know when things happen. If they're going to do things automatically. So that means if they're going to extend the cylinder, they need to know what? When it's extended. If they want to retract it, they need to know when it's retracted. And they can't depend on the time. Because if it's not a temperature compensated flow control or pressure compensated flow control, that means what's going to happen is that if things change, your speed of your cylinder could change. So if I came over and said, well, it takes 5 seconds to extend that cylinder, well, that might be 5 seconds in the summertime, right? But it'll be what? It'll be different in the wintertime, right? So that's what those 1V1 and 1V1 say. So what we need to do is we need to find a symbol of a cylinder with a cushion. Where we're going to go to? And that's not in that book. I could have swore it was in there. I know I spelled. So here's your cushion. I just got it on the wrong side. So here's the symbol of a cushion. Oh, this is the one. This is the one that I was using right here. So I was right. So if we see that on a symbol, it means it's got cushions. If we see it with an arrow through it, what does that mean? So see the one down on the bottom left up there? Well, there. But the cushions are actually tubes inside there, but for some reason when they drew it where they drew it actually on the piston itself. So that other little symbol, that little U-shaped symbol, that's the symbol of a magnet. I don't see my PowerPoint. I didn't close it out. Here we go. So this is basically how the cushion works. So you come over here, and when it goes back into there, what does it do? Yeah, it's only got one path to go, so it goes through those narrower channels. Controlling the speed of a cylinder or an actuator. The time of a cylinder will fully extend or retract is determined by the volume of the fluid needed by the cylinder per stroke and the flow rate of the fluid. We looked at this already, right? So flow rate is equal to, so time is equal to what? In square inches. Length is the stroke length. And then the time is in. Are we okay? Is that one in the data book? Yeah. Should have two. You should have speed of a motor, and you should have one for speed of a cylinder. Because the formula, this is cylinders. When the cylinders were pushing against an area on a motor, we're pushing into a displacement, right? So does it have that? Yeah, the speed of the cylinder. What's the actual formula? And like I said, I don't have a copy of that real good. This is the one. So the velocity would be, this is the velocity. Y'all see this formula there? Is that the one that's in the book? Yeah. Okay, so that's the same formula, but here what they're doing is they're converting it over to feet per second. Are we okay? Is this the one in the book? Huh? 231 times flow rate in gallons per minute, divided by 12 times 60, times the area. Now what they've done over here on this one is they split this over by itself, and then they went ahead and done the math for us. And so they said velocity is equal to this number, 0.32. So what they did is they took all the constants over here and went ahead and did the math. So Q is the flow rate divided by the area. So you understand what I'm saying? Yes or no? So they took the 231 and divided it by whatever 12 times 60 is, and then they came up with this number, 0.3208. But it's still the flow rate times the area, which is the basic formula that was in our slides. But what they're doing here is they're taking gallons per minute and converting it over to what? Feet per second. Now, what would I do if I wanted to go to inches per second? I take just the feet. Just the feet, right? You understand? I could take the 12 out over there and divide. Or I could do what? I could take my number and then, not divide it, multiply. Multiply by 12. So it's 12 inches. Are we okay? So this is the one that's in the book, in the data book. With the speed of an actuator. Do they give you the speed of the motor? Yeah, so here we do 231 again to convert it over to distance. And then we take the FM is the fluid motor. But here we're going to use the watt. The displacement. And what is it? That's cubic, and we already talked about this. So displacement is the number of cubic inches per revolution, right, of air that it can, or fluid that it can move. And then our answer is going to be in revolutions per minute. If we wanted to go to revolutions per second, then we would take our answer and multiply it by 60, right? I'm sorry, divide it by 60. So here's our speed of our actuators. Of course, what we're talking about now is this guy right here, the cylinder. This is on the website, by the way, on Blackboard. Should be in. Let me make sure before I make that comment. Should be in reference material. I'll find the class. Here we go. So there should be under course content. Yeah, it should be one called reference material. And then there should one be called fluid power formulas. So that's the same one. So guys, if you can't afford the $1.25 reference book, and there's a lot more material in there except just for formula. I will allow y'all to print this off and during the test. I know $1.25 don't seem like much, but when you don't have any money at all, that's a lot of money in it. And it's a neat little book. I mean, it's got a lot of stuff in there. Sure. What do you want to do? Tell me. So what do we need to know? So let's look at that. Let's say I've got a cylinder that I've got a flow rate of, we'll do hydraulics. I got a flow rate of, does it give us compressibility, valves, viscosity, pump efficiency, actuator formulas? Huh? Okay. Y'all supposed to turn in a worksheet today anyway, so let's go ahead and see if we've got those. No, there was a worksheet that was due today, worksheet 1. Talked about, well, you didn't have to print them off. I told y'all could do what? you just write the answers. That would have been fine with me. If you want to run them off, that's fine. Sometimes it's better to do that. But just turning in the answers would be okay with me. So that'd be under course content, worksheets and quizzes. So guys, I do a couple of things. First of all, anytime we have a worksheet or something to do like that, I come in here and I post it on the announcement section. And when I post it on the announcement section, I also tell it to send it out by email. If you don't check your college email, if you don't come in and check the announcement, if you don't check the course calendar, there's really nothing I can do about that. And plus, we have a big problem with this class getting here to time. So at the start of class today, they have 3 people. So what we started to do every day, every morning, I'm coming in here. If y'all all start coming in at on time, we won't have a problem. But we're starting to give we're giving a topic quiz every morning. And we all try to come in here on time. And I think I've told y'all this, and I'll tell you that again. When an employer calls me and asks me about a student, I get 2 questions all the time. Now it varies, but the 2 questions I get all the time is, do they show up on time? And how well do they work with us? That's the 2 questions I get all the time. I mean, probably 99% of the time when they call. And the best reference I can give you is, I would hire them. But you got to understand, if you use me as a reference, that is not the caller. That is a person, right? That is a reference. And I don't lie to people. So I said, yeah, they do real well in work. They just don't ever show up. You know, these guys.
Yeah.
So y'all need to make efforts on this. And so what I'm doing, guys, is I'm giving, and it says in your syllabus, if you miss work due to being tardy, that can affect your grade. So that's the only thing I can do, guys, is affect your grade for not doing it. So we've been doing that. So the last 2 days, if y'all hadn't been on the test, then you've missed the topic quiz for the last 2 classes. These will be averaged into your assignment section, homework assignment part of your grade. So I send you email. I post it on the announcement. I send you an email. I put it in announcements. I think if I come up here and look at the course calendar, 30th, what does it say? If I come up here and double click on that, it says worksheet due. So I don't know, guys. I don't know what else I can do for you to be able to get these worksheets on time. Say, well, you could do them for us. But we do, huh? Yeah, worksheet 1. I need to see them. So turn them in. Huh? Is there a stapler? There's a stapler. Here goes. Isn't there a stapler right there? Where's the stapler in here, guys? I know there's a stapler in here somewhere. What we're doing too? Y'all find it? So let's leave it over on the piece, huh? Yes, we'll go over it. Yes, that's fine. Oh, I don't know. And by the way, if there's a worksheet due and you happen to be absent, what can you do? You can email it. worksheet is located, the hydraulic cylinder worksheet is due at the start of class. The worksheet is located on Blackboard this didn't show up like that, guys. This is, originally because I added it. These are they're quote marks there is what they are. Course content / worksheet and quiz. I don't know what to do. What else can I do for y'all? I don't know. So somebody said they wanted to do a speed. What do y'all want to do? Is there one on the worksheet? What will be the pull force? What will be the push speed of the cylinder? So what the information they gave us here on the worksheet is, You don't remember which one they were? What would be the horsepower of the circuit at 85% efficiency? So if somebody, Jacob didn't answer that. So right now we're working with speed. So this said, so what does this one say? What it says, what would be the speed? So this is what they give us about the cylinder. They give us, it's a 4-inch bore. With a 2.5-inch rod. And we're running on 3,000 psi. And the flow in the circuit is 8 gallons per minute. Okay, do we have everything we need? Somehow close that gap, yeah. Oh, that's right, where I wanted to be. Dang it. So course content, and of course if you got your data book, that's fine. Reference material, and then speed, right? So power formulas. Cylinder speed. Okay, so what are we given? So what formula are we going to use? We're doing the cylinder flow, the cylinder velocity. Well, the push speed and the push speed and the pull speed, or the extend speed and the retract speed, are going to be different. And why is that? 3,000 psi. Well, we're not talking about the force right now. We're talking. You're right. We're going to create more force to extend than we will retract. But what we're talking about now, we're talking about speed. Right? And here's the formula right here for speed. What's the formula for speed? 231 times what? Times the flow rate, gallons per minute. But right here, what does it say? What's this right here? The net area. So what that means is your extend or your push area is going to be bigger than your retract area, right? So what does that mean? Well, if we're dividing by area, that means the rod would retract faster than it would extend. What was really neat when we had our hydraulic trainers over here, we had a hydraulic cylinder across the top. That thing must have had a 36-inch stroke. And it was so neat. So that was long enough so we could actually measure this thing. And then we would do the math. And we'd come over here, we'd put a stopwatch on there, and it was amazing how accurate it was. When you could actually see it doing one. Retracted faster than it extended. I don't know if we're going to see ours because ours only got what, maybe a 12-inch stroke. I'm not sure. I think that's about right. Y'all extended the single action cylinder. I don't even know if it's 12. It might be 8. Yeah. So the problem there is if it's so slow, so fast, we could. And another problem we have with our lab is we don't have a dang flow meter. Which means what? We don't know the flow according to this, so we can't calculate the speed. Odds are we can see it expand and retract. If we lower the speed, we can see it expand and retract different speeds. But we're not going to be able to do the math over in our lab because for some reason the kit does not include a flow meter. Our hydraulic trainers had the flow meter on, which was pretty neat, so we could do the math. But here, so what we're going to use is a 232 times what? Times the gallons per minute. 231. I'm sorry, I wrote down 231. Divided by 12 times 60, which is okay. You can do all this if you want to, but I'm going to use this formula on the right because it's done a lot for me. So I'm going to use 0.32. They've done all the math for me. 0.3208. And then I'm going to multiply that times the flow rate, my gallons per minute. And then I'm going to divide that by my area. So let's do the area. So the pull, what was, it was 4 inch. So what would be the area 4 inch? Yeah, how do we calculate the area? Yeah, good. Good. Well, no, 4 squared is not 8. 4 squared is 16. And that's a tendency that people do is they'll see 4 squared and then they do they multiply it by 2 instead of actually multiplying it by itself. So first thing I'm gonna do, okay, so I'm gonna take this what? Yeah, that's so neat because we could do all that math, but you'd have to use a bunch of parentheses. 0.33, and this is a number I used to know. And then I'm going to multiply that times a gallon per minute. What we say our gallons per minute was? 8. And then I'm going to divide that by our area. We'll do both of them. So my extend area, or what they're calling my push area, is going to be equal to 4 squared times 0.785. And then my retract area, or what they're calling the pull area, is going to be 4 squared minus 2.5 squared times 0.785. So what's my extend area? 12.7? This would be square inches, right? And then what's my retract area? So we'll just take that and put it on here, and what do we come up with on our speed? Yeah, that's what it is, by the effective area, I think is what they call it. So this would be 12.7 or whatever y'all said, it's gonna close. And we're gonna say 0.3208 times 8, that's, and then divide that by 7.65. And that would be our retract speed. So our track speed is going to be faster. What's that? Yeah, this is what the book is calling push, and we're calling it extend. And then the retract is what Nancy is referring to as pull, which is pretty well self-explanatory, in my opinion, in my own. I think the only one you didn't answer, Jacob, was the horsepower. 85% of what you would do is you just multiply your answer by 0.85. Well, that's what you put. Anytime you're doing efficiency is going to be a percentage or it's going to be a fraction. And what you would do is, if I said 85%, that means I would multiply my answer by 0.85.
But the formula I got was, we're talking about
minus
horsepower?
Yeah, minus efficiency.
Well, I did the PSI something down per minute, 1714.
Yeah, that's right. But then it's got, yeah, but you should have multiplied that times your answer. Not put the 0.85 on the bottom. Understand? So what you would do, Justin, is you calculate your horsepower, and then if it was 85%, then you would take your answer and multiply 5%. If you put it on the bottom, then you would actually end up with an answer bigger. You'd end up with more horsepower than you started off.
So, force, push force and pull force is the same.
Well, push force, what we do, so our push force is going to be equal to area times pressure. That formula is. Pull force is going to be equal, this is area of the piston. And over here, your area is going to be area of the piston minus area of the rod times the pressure. Which is strange, but what happens is you got to understand, and if you understand physics, you understand we don't change work. Work in equals work out. So what happens if work is equal to force times speed, and my power in is equal to my power out, that means if my force goes down, to come up with the same answer, if my force goes down, my speed's got to go up. If my force goes up, my speed goes down. Because we don't create energy, right? What we're doing is taking it and changing its form. So if my system was 100% efficient, that means if I needed 3 horsepower worth of work, my pump would provide me with exactly 3 horsepower worth of energy. Because all we can do is change its form. So if everything was 100% efficient, whatever power I'm getting out is whatever power I'm putting in. It's just like in power amplifiers. You know, if you get 400 watts out, you got to put at least 400 watts into the amplifier to get it out. So your amplifier is not creating power. Your power amps are just managing the power that's already there from your power source, which would be your electrical system in your car, to the output of your speaker. Of course, unfortunately, power amps are not 100% efficient, so it depends on what type of amplifiers you use. In fact, Class A amps are only like 25% efficient. So that means it takes a ton of power to run those things. Class AD, which is the hybrid AD, would be the most efficient. Those are around 90%. And that's usually what your outputs are. Your outputs are usually Class AD. Well, the Class ADs put out the power. It's the Class A's that.
No, I'm saying they put out, but like for high power meters, you have to do it like
Class D, but it's the same thing. It's a modification of a
Class A.
I don't know. For what?
On the top one, I got 20.
But pop point. Now this is going to be feet per second. Right? You understand? If I wanted to convert this to inches per second, I would multiply my answer times 12. But the formula gives you, if you do the formula book, your answer is going to be in feet per second. But it's real easy. We know that we can either leave the 12 off the bottom, or we can go ahead and do the formula and multiply by 12. So they didn't give you a feet per second. But y'all understand? If you leave the 12 off the bottom, it would be just like doing what multiplying there.
You know, the real book is just a different form. What I did, and my answer is hard. But if you look at the chart for the cylinder speed, you go for a 4-inch diameter to 2.5-inch rod.
Yeah.
The answer is kind of close to it.
What is the answer in the chart there?
I mean,
So what answer did we get here? And what do we get here?
bottom point
335? So
no,
just
I did a form from the book. You know, I did a 231 gallons per minute to mine on the air.
yeah, but if you just use the area, your answer is not going to be in feet per second. It's going to be what you come up with. So what did you come up with?
It came out to what? I mean, yeah, the book says feet per yeah. Well, I came out to 147. But then
147?
See how if you look at this chart, you didn't.
So let's multiply this answer by 12 times 60. And let's see what we come up with. So what's 12 times 60?
I'm talking about this one. This is what I used to kind of that. That's just wrong thing.
No, it's not. It's the right point.
Because this is like 231, the 12 inches, they're usually 12 down from the 8, and then I divide line on the area. Because in Diana, but if you go right here.
Yeah, but right here, this is feet per minute. And this calculates feet per second. That's still not going to come up here. When we come over here and say we have a what, 4-inch
Or
line.
no, this is
This is big.
So
See, I got the same answer.
right here, I got 147, but that's not right because we're using a 2.5 rod, inch rod.
Well, this is the piston. So you should have came up with 8 gallons per minute, 147.
which I did, but this is for your little rod and
Yeah, but that would be the answer up here. This would be your other answer down here. So this would mean, this would be your piston without the rod. So it should be, yeah, so this would be 147. And then this right here would be your piston with, this would be with the rod. So this means this would be the non-Rodian, right? And then 2.5 means the speed would be 241.
but that's not even close to what we got. You see what I'm saying? I'm kind of confused.
Yeah, I can understand that. It depends on how you come up with your answers. So what did we come up with there?
On the book,
Of course, it doesn't mean we're not doing something right. So 0.2 times 60. That times 12. Yeah, but I dropped off that. So see, that's our difference right there. So the formula in here, what yours is, what your answer is, feet per minute. And what this thing is what in feet per second.
so if I'm using this, I got to divide by 60
If you want to go to feet per second.
seconds.
Yeah.
Well, which one you got?
Well, I don't know. I don't know what the worksheet says.
Oh, yeah, it doesn't even say.
Yeah, so technically, y'all listen up. Y'all listen up. This is a really, Justin came up with a good point. And we just proved it. Yeah, so the formula sheet that I have gives the speed in feet per second. This book right here gives it in feet per minute. Okay, no one's done that. Yeah, but if you take that point 202 and you multiply it times 60 times 12, then it'll come up and give you the exact answer that's in the answer book, which is 147 for the rod. And then, so this one is in there, so it's in the food book. If you look back on that table, and that's a really good table, it's going to save you a lot of math. Well, no, but what the book is going to give you, it's going to give you feet per minute. What we're getting is inches per second. Okay, y'all understand that? Yeah, that's what I'm saying. The book, it's fine. So both answers are correct. Y'all understand that? So what I would do is so think about this. So if I came up here and took that answer, which says 147, and I said, well, if I divide it by 60, that's going to give me feet per second. And if I divide that answer by 12, that's going to give me inches per second. So what answer do you want? Well, in the test, it's going to have to be defined. Where do we want inches per second, or do we want feet per second? Okay. So the formula sheet that I downloaded is inches per second. The data reference book is feet per minute. So the formula would be exactly the same thing. All I would have to do on this formula is just leave off the 12 times 60. All right? That gives us, if y'all understand what I'm saying, yes or no? Yeah, so notice what this is in velocity in, this says feet per second, guys, but I'm almost sure this is inches per second. Because what they've done on yours on the bottom one is they've left off the what? They left off the 12 and the 60. So you have 231.
Well, this booklet's on my
Okay, so this gives you feet per minute. Yours is inches per second, right?
This is deep.
Inches per minute.
Okay, inches. Let me get this right. So yours is in inches per minute. This formula is for feet per second. So you look, the formula is exactly the same if I leave off the what? The 12 times 60. So what they're doing there is they're taking the inches per second and converting it over to feet, and they're taking the minute and converting it over to second.
That's long.
Yeah, it is, but you can still. So the 3875 is. So you're right. This is the long way, because here you got a bunch of math to do. Over on that one, you just take 231 times that, and then if you wanted to go that, then you could divide it by 60 by 12, right? And then that would come up and give you feet per second and stuff. So if I wanted to go to inches per minute, then I would drop the 60, right? If I wanted to. So which formula is right? Both of them right. So what did we come up with? Well, we come up with 0.202. Well, if you took 0.202 and you multiply it times 60, you multiply it by 12, you come up with the same. So look at the test. Odds are the test. I ain't looked at the test yet, but I'm almost sure the test matches that book. Which would be what? Feet per minute. I'm sorry, feet per second. I'll get that right in there. And what's nice about that is we have standard cylinder sizes and we have standard rod sizes. So what do they give you in that book? They give you a chart. What page is that on, Justin?
1750 to 1750.
Okay, so look at, if you got your book, look at that. And that's what's really neat. So look at a 4-inch, look up a 4-inch cylinder, a 4-inch bore. And then look, just follow over for 8 gallons per minute, and it says 147. Now notice that's the none, and that means you're not subtracting the rod, so that's the piston. So to calculate the push, I would use the none row, right? You understand? And to calculate the pull, what I would do is I would go down and look at rod. I'd look at 2.5, and then I'd follow that over, and it comes up and gives me what? 141 feet, right? 241 feet per second. It's pretty neat. But we should have expected that. So the rod end is going to travel, it's going to produce less force, but it's doing the same amount of work. Right? You understand that? So it's going to have to do what? It's going to have to move faster. So it's strange. People think that if you reduce the area, your speed's going to go down, but if you reduce the area, your speed's going to go up. The word goes down. So which formula is right? Okay. So let's see what they do down here for the motor speed. So speeds and revolutions per minute. That's usually standard. Usually when we do motor speed, they're rated in revolutions per minute. Per minute, so you don't have to do any extra math there. But you do need to know what. So one of the things they're going to give you in your data sheet and I think there's some data sheets on here. One of the things they're going to give you is the stroke, and they're going to give you the what. They're going to give you the air. They might not give you the area, but they're going to give you the volt. They give you the size of the cylinder. They might give you the area too. But if you've got standard size cylinders, then the odds are somebody's came up with a chart. Well, not only a formula, but they came up with a chart where you don't have to do that. Unfortunately, mine does not have that chart. And even if it's not a standard symbol cylinder, odds are on a multiple choice test, you can eliminate answers. Pretty easy. By the way, the first part of the test is going to be written in it, so I like this worksheet. So, like I said, so fluid power, horsepower. And what's the formula for horsepower?
There's a bunch of
Foot power torque, foot power motor speed. 1714, that's the number. And that's for what's that for, Justin? Just horsepower, right? And then, of course, the way the worksheet says, it says calculate the horsepower, and then it says at 85% efficiency. So y'all okay on that now, right now?
So after we've done horsepower, divided by.
Multiply. Yeah. So remember, percentage is real neat because it gives us a feel. So if I say 85%, people understand that. If I say 0.85, they get lost. So the way we go, the way we actually calculate the amount of percentage is we just use the fraction represented by 85%, right? And what do? You just take the 85% and move the decimal point over 2 times to the left. So to calculate the actual number, if your boss says, I'm going to give you a 30% raise, then what would you do? Well, you take what you're making now and you multiply it times 0.3. And then you add that on to your salary you make now. People, for some reason, understand 30%, they understand 50%, but then they don't know how to take the percentage and actually go to the true number that represents, which would be a fraction. And that's just a common mistake that everybody makes. So guys, I'll look up another one. I'll try to find another forming sheet. I thought this was a really, really neat one. But it looks like the forming sheet that they're using here does not, it looks like the formula sheet here, even though these formulas are valid, they don't match that data book. And I can almost guarantee that when they get the test for this class, that they're according to that book there, not according to the formula sheet. I bet you money.
According to the little book.
Huh?
According to the little book.
Little book, yeah. Because Nancy, this was Nancy's class before she turned it over to Donnell. And so most of the tests and everything was set up by her, and she's been using this data book. Like I said, 5 years ago when I taught the course, she was using this little data book, even though the book itself was different. And like I said, the test, the review for the test is already up there, right? No, test is Wednesday. Guys, I don't know what else I could do. I mean, I've already put I put a calendar up there, and the first thing I do when I put a calendar up there is post to what? Post the test date for the entire semester. I put them up there. So I don't know what to do.
It's not in the area. There's nothing that's
There. The worksheets are not up there until they're due. Because we don't want y'all trying to do. Yeah. So if there's any quizzes, I don't know. I didn't name that section. So I know I saw it all.
Did anybody?
I'm asking.
The only thing that I know of that you have to turn in, y'all listen up, guys. The only thing I know that you have to turn in is worksheet. No.
Do we do this question? Yeah, go ahead and get that done.
We can sit there and learn tomorrow. That's late, yeah.
Okay, one question.
Oh.
What we're gonna do, the rest of the class, everybody okay?
I'm all right. I just gotta get one of those.
Yeah, those are gonna be, huh? By the way, what we're gonna do Wednesday, what we're gonna do Wednesday is we're going to be in lab the first of class, and then we'll take our test the second part. Because remember, on a midterm, every class counts as 2 classes. So why we put it at the end of class is that if I did it at the start of class, that means when you finished up, you would have to hang around for the second class part of that. But when we give them at the end of class, what that means is that when you get through with the test, you can do what? You can leave. So we'll be in lab the first part of class, and then we'll be in, now if you didn't finish up lab 1 and 2, then you need to stay and finish it today, right? You understand? Everybody understand that? One of the first labs we're going to do when we come in Wednesday, the first lab we're going to do is we're going to inventory these things training. Make sure everybody gets the parts they need in that training. And like I said, it's okay if you move parts around, but you need to do what? You need to put them back where they go. And in that way, we spend a lot of time doing what last class? So some people didn't get through with their labs, and some people did. Well, probably the ones that didn't get through with the labs are probably the ones that had to do what? Find the part. And we spent a lot of time hollering out, does anybody have this? Well, that's what we're going to do. When we come in, we're going to come in and inventory our trainers, and I'll explain it. I'll write it up for y'all. So the parts you find extra, we'll put them on a table. And then if you don't have a part, you'll do what? You go up to that table and they should be there. Okay, so if you're still working on lab 2, or 1 and 2, you need to stay today. And if you finish with both of them, then free leave.
I need help with this math.
With the math.
Do we have a,
I just never turned it in. Never signed off.
Well, I need to see it. I gotta see it. It's like the last time I got it.
it's in there.
Why, Austin?
Huh? Well,
Why do I have to see it? Why do I have to see it?
Validation.
Well, I didn't see it at the time I was supposed to see it.
Okay. Yeah, I apologize. I didn't bring my laptop in because I hadn't had it. I picked it up twice. That's why I was late this morning. I was like, late at twice. I was this good within the first 5 minutes of class. Walked out the door, somebody with a power.
That's the
Laptop, grabbed my laptop. Then I hit my alarm and I get 6 seconds. I was still thinking, I hate that this morning. So I run in the kitchen, grab this, and fly out the door, get in the car. And the whole time I'm sitting at the end of the ride, I'm like, I forgot something. I was like, packed my pockets, got phone, got my keys, got my phone, like, now I'm doing it. Then that's why I sat outside for like 10 minutes in the car. I was like, what did I do? I was hoping I was like, I know I ain't put it on top of the car, so back out the garage.